Hi guys, Mrs. Wolf here. I wanted to go over your case study to help you get ready for your CBC lab this week. So we have this guy named Harold who's 67 who wasn't feeling very well and went to the doctor. The doctor decided to do some blood tests, a smear, and a quick little blood test to give them the different ranges so we could see what was going on. Okay, so if we come down here, if it'll let me, here we go. You can see the smear on the right-hand side. And Harold's is on the left of this picture, and normal is on the right. And automatically, I see a difference. So when I was reading through, I gave myself some notes underneath that I said there aren't as many red blood cells, and these red blood cells are bigger. So I wrote that down. And I wrote it just under the picture to help myself. Then I went through these measurements over here. These are all the different things that they were looking at in his blood. His results are the middle column, and then the ranges they should have been in is in the right-hand side column. So the first one's white blood cell count. There's 2 here. There'll be 5 on your actual CBC lab because there's 5 different types of white blood cells. But you can see his white blood cell count is up, so I drew a little arrow saying it was too high. And then the neutrophils were also a little high, so I drew an arrow up next to it. And then the basophils are high also, so I drew a little arrow up saying it was high. Then I came down to red blood cells, and everything underneath, or at least the 3 underneath, have to do with red blood cells. This one looks low, so I draw an arrow down. Your hemoglobin, it looked low, so I would draw an arrow down. Your hematocrit is low, so I would draw an arrow down. And then the mean red blood cell volume, or sometimes called the MCV, is high. So I would draw an up. And then platelets down here, they're kind of their own thing. And they're within normal range, so we don't have to worry about those. So then you come down here and use the values of what we just looked at and kind of put them in to their own little section. So anything that oxygenates your cells, so anything in the blood that has to do with red blood cells, would go right here in this column. So I have red blood cell count, hemoglobin, hematocrit, and MCV. Now, red blood cell count just tells you how many total, volume-wise, how many red blood cells you have. And really, that one goes together with hematocrit because they're about the same thing. It's really about how many red blood cells there are. Hematocrit has more cells in it, but there's so many it's such a little amount of white blood cells that they can really just look at the red blood cells in the hematocrit. So if they're too big, if the MCV value is too big, or we look at the slide and we see that the cells are too big, they're called macrocytic. And if they're too small, they're called microcytic. If they're too small, obviously they can't do their job well. If they're too big, it seems like they would be able to carry more oxygen, but they don't. They're inefficient. They still have a nucleus. They're immature, so they're not really doing what they need to do. Okay, so then if we go down to immune response, all your white blood cell stuff should be in here. So your white blood cell count, your neutrophils, your basophils, and any other ones you're going to end up with on the CBC lab. But anything there that's too high or too low, if it's too high, it's really going to be an indication that there's an infection or an allergy immune response of some sort. Obviously, with red blood cells, if it's too low, it's going to probably tell us that it's possibly anemia. Then hemostasis, right here would be your platelets. Okay, so then if we come down here, all those things that I drew arrows next to, we would list them right in here. So white blood cell count being high. Then I would put the neutrophils being high and the basophils being high. And then I would put hemoglobin and hematocrit kind of together because they're kind of their own thing. They go together with the red blood cells. And then down here I put the MVC, okay, or the mean red blood cell value, okay. And then down this column in the middle, I would put any kind of things that would happen because of those differences. So if I had a high white blood cell count, right here I would put that would maybe cause a fever or tell me that there's an infection or inflammation or dizziness or chills, and they kind of go together, those, right? So the 3 white blood cell group, I actually put like an arrow and put them together and wrote the stuff all together in this column. And then over here, some of them I arrowed over. Obviously, Harold's symptoms, he did not have a fever, so that would not go in this column, but most of the other ones would most likely come over, and you could just draw an arrow for the ones that would. Then for hemoglobin and hematocrit, you would list fatigue, shortness of breath, dizziness. Obviously, he has a lot of those, so they would go in both columns. And then the last one, the mean red blood cell value, obviously, would tell us if the cells are too big or too small by looking at the smear, too. So that's what we could put down here. What is anemia? You could describe anemia, not having enough red blood cells circulating enough oxygen to the body. Give some examples or describe the condition. You could say the person's pale or their extremities are pale. Their nails, beds wouldn't look pink anymore. The inside of their lips or around their eyes wouldn't be as pink as they normally would. Anything that would be indicative of not having good circulation. And then primary pieces of evidence that would point to anemia, you could put the low red blood cell count, the smear that they looked large and there weren't as many of them. Just the fact that all of the red blood cell counts were pretty low, right? Except for the MVC. And that would tell us something's going on and he's not getting enough oxygen. Then down here to number 2, it talks about his stomach and how the lining is being degraded or thinned. And he had an upset stomach, and the doctor orders tests to check his B12 levels. So there's no absorption that goes on in the stomach, but there's a lot of chemicals that start the process of breaking down food chemically as well as mechanically to help it absorb later. So B12 actually is absorbed in the small intestine, but there's something in the stomach that helps it begin to be pulled out of the food that you eat. So due to the damage in his stomach, it is not making that chemical, or intrinsic factor is what it's called, to help his body absorb it later. There's actually medicines that people take sometimes, things called proton pump inhibitors. If your stomach is too acidic, your doctor might put you on a proton pump inhibitor. Well, that could block whatever the chemical is that you need, the intrinsic factor, for the B12 to be absorbed later. I know that because it has happened to me. So then it says, what type of anemia is he suffering from? Well, B12 deficiency, right? He doesn't have B12 as much in his system as he should. It was low. The B12 deficient anemia can also be called pernicious anemia or megaloblast anemia, just saying that those red blood cells are large. Okay, so what happens? I know what happens in number 4 because I had to do it. I did not have any B12 in my system, and I was exhausted all the time, and they had to give me 10 weeks of shots of B12 right into my bloodstream. Okay, so kind of jumpstart my system into being able to make red blood cells again properly So you need that B12 to help your red blood cells be made correctly, not too large, right? And then if we go down to 5, it says Harold has tachycardia and chronic gastritis. We know that, but it wants to know which one was first, the chicken or the egg, basically. So, is tachycardia first, which actually means your heart's kind of racing. It's kind of trying to catch up, push the blood through your body so that you can get enough oxygen. Or chronic gastritis, did that come first? So I would say, and probably most doctors would say, that chronic gastritis came first because that blocked the B12 from getting to where it needed to be, which then you didn't have enough red blood cells in your system for the oxygen to get everywhere, so your heart starts beating harder, faster to get everything through your body at a quicker pace to get oxygen to all your tissues. Okay, so hopefully that was helpful in giving you a synopsis of Harold and some of the values that you're going to use in your CBC lab.